So you can see that the insides of Mplus version 8 it contains quite complex statistics. So we're doing the peaking on the difficulty level according to the chi-square distribution. It peaks very early today. So after this, everything will be much easier to digest. And you can also see why Tiemer's PhD actually was in mathematics at Caltech. And you can see why Tiemer, when participating in an international competition in mathematics in high school, won. That was in China, was it?
Uh-huh, yeah.
So with that, any questions? You want to quibble with some formulas?
Definitely not quibbling with formulas, but question I had about the latent centering. If the mean for each person, if that distribution is not normal, really skewed, is the latent mean then going to be biased, the latent centering?
So I think, are you presenting something on that or no? So generally speaking, when the size of the time series is sufficiently large, the assumption of normality, which is essentially the between level model, that's your assumption of normality is the, so the between level model essentially you can view as being the prior for that autoregressive, for the mean. And as long as the time series is, say 50 time points, then this between level model has a fairly small influence on the estimate of the mean. So it's.
I'm just curious. Say I had like a daily diary study for, say, I've got 25 days, and I've got like something like suicidal ideation, which is pretty skewed. Would then you think it might be a problem?
If I can add to that, I'm going to talk about that this afternoon. And I would say that might be on the limit of what could be a problem if it's very skew. But we saw that for very skew distributions of the autoregressive coefficient, for example, time points larger than 30 seems to be kind of the point where everything is okay. So depending on how skew it is, 25 might be a problem, might not be a problem. But that's kind of where the limit is, where the border are.
But of course, it assumes that linear models are still relevant, which may not be the case when you have suicidal ideation, because you probably have a strong floor effect, which is an issue. Like we talked about the first day, how to model variables that have that situation.
So yeah, and Nikiel's bias is a little bit of a undeveloped story there. So we talked about Nikiel's bias being the mean of the autoregressive parameter. That's not the whole story. The story is that whatever misestimation of the autoregressive parameter occurs is probably not just a simple shift of the autoregressive parameter. It's probably all over the place. Those simulations that I showed you, they were applicable just for the mean of the autoregressive parameter. There could be like a vast thing going on behind the scenes that if you average things, it will look better than it actually is. If you actually look through the mean square there between the true autoregressive parameter and the estimated autoregressive parameter, that would actually probably look worse, just because of the fact that it's probably not going to be just a simple shift between the true and the estimated when you use the observed centering. So, but ultimately, I would not worry about the distributions of these random effects. And the reason it is because as the cluster size increases, that assumption about normality of the random effects, which is essentially the between level model, becomes much less important. The data on the within level drives the estimation of the random effect. And so, no, it's not going to affect anything. You can try it in simulations, to, convince yourself, because I'm not very convincing. It's kind of, but, but this is the reality. It's not, you're not going to find anything. Yeah.
And I will show some simulation studies of that this afternoon as well, so we'll talk more about that.
And I'll show an alternative modeling that tries to take into account that floor effect. All right. Any other questions? Over here, yeah.
Thank you. I wonder, could you provide some concrete examples of where the DIC criteria could be used to kind of examine the fit of different models, as well as where it falls apart, such as maybe comparing lag 1 versus lag 2 may not work, whereas perhaps adding fixed effects could. Just something concrete might help at least.
So you can DIC, when you can use DIC, so you can use it to, if you want to see if an effect is random or fixed, no problem. You can use the DIC to do that. You can use the DIC to compare models that have different set of fixed parameters. So whether a set of covariates, say, should be included or not, that can be used. And do you want other examples that are cannot be used for? So in contrast, I would say that an example that you cannot use is so if you have a factor analysis model with an autoregressive equation for the factor versus a model that an AR1 model, so each indicator has its own autoregressive equation or a joint, that will not work because that cannot be used because the factor, if the factor, whatever factor you have in there and it has an autoregressive equation, that factor is going to be conditioned on, and so it's going to be completely different likelihood, and you'll be it will be easy for you to see it. It's just not, for me, when I say these things, we have to go and say it so you're not shocked when you find out about it. One way or another, you will find out about it. But actually, the reality is that I personally don't have any problems using DIC. Banked using just Ellen is the problem. So.
Do you want to comment, Ellen?
Don't get me started. No, I think one of the major disappointments for me was when I was running a multi-level model, factor model. Sorry. So the model that I ended with yesterday and that I will talk about later today, I was interested in finding out whether the factor loadings within person were the same as the factor loadings between person. So then I constrained the factor loadings. So I ran two models, one in which there were no constraints and one where there were constraints. And there seemed to be a difference in DIC, but I wanted to make sure that the DIC was stable, so I tried out the same model, but with a different seed, so to the same number of iterations, but just starting with a different seed. And I found differences, so it should be more or less the same. And right. I ran like 1 million, or maybe not 1 million, 500,000 iterations. It took a bit of time, and then the difference in DIC could be like 200 points. And when you look at the rules of thumb that exist for DIC, it is like, okay, 2 points is not a big difference, 6 points is quite some difference, and
right. So these rules don't apply. These rules don't apply here. Yeah, you have to. When you have 10,000 parameters, those rules don't apply. You're going to have to run essentially, a reasonable amount of iterations, so it's not even practical. However, you are able to do your testing. For the reason is that the difference between the two models was much larger than 200. Correct?
No.
No, I think it was correct.
No, so
No.
For me, this was the point where I thought, okay, so I still don't really understand when the DIC is comparable and when not. I just admit this, I just don't get it. And I've been trying to get Tiomir to explain it to me, but I don't get it. I understand the general idea, but I don't understand when I'm in one situation and when I'm in the other. Yeah, so for instance, you were saying an observed AR1 model and an AR1 model with measurement error. Are these comparable?
Say this again?
The observed AR1 model and then what you call the MER model.
No, they're not comparable because one of them has a factor that's conditioned on and the other one doesn't. This is, you can see what's you can see.
For me, I just don't understand what he means when he says a factor that's conditioned on.
This is the healthy give and take within this group.
This we do through email,
After now we sort of have an algorithm. We are sort of ready to get to it to actually get this resolved in 8.1. So you won't have this vast amount of parameters, and then the DIC would be better, easier to use.
But what about models with categorical outcomes? It still is based on maximum likelihood estimation behind the scenes.
Yes.
And therefore we sort of put DIC aside and go for some other model comparison.
Yeah, exactly. So in the plan is to actually, it was actually in the plan for version 8, but we didn't get to it. But in the plan is actually to have the model test, which is much easier to estimate a hypothesis like this. Just have the model test statement inside the Mplus, and of course it's fairly trivial to do it. You can even do it yourself, outside of the program. But
just to emphasize that's a great idea. We have the command model test, and you use it quite a lot in the ML framework. It doesn't exist yet in the Bayesian framework, but what Tim is suggesting is that quite easily, relatively speaking, he can add that to a new version of Mplus, and that will be really an important way to compare model parts.
Yeah.
In the slide 62, the y star 0.05, are you constraining the variance of the zeta and eta to the 0.05, or variance of zeta only to 0.05?
So that basically is the residual of the y. So it's this residual right here. And that's basically the residual, that's the extra residual. So we wanted to estimate this model, but we end up estimating this model. We want this actually to be either fixed to 0.
Can I ask you, should this variance be the variance of epsilon, not z?
Yes, that's correct. Yeah, that is a typo here. So that should be that epsilon t. Sorry.
Thank you.